Hello, everyone. Good morning, dear authors and invited guests. Welcome to the technical session 5C. My name is Siddhi Auti, and I'll be your moderator for today's session. On the behalf of Global Knowledge Research Foundation and GR Scholastics LLP, it is my great pleasure to welcome you all to the ninth International Conference on Smart Trends in Computing and Communications, SMARTCOM 2025. The ninth edition of the conference is being held in hybrid mode. The physical event was held yesterday in Pune, India, and the virtual event is being held via Zoom meeting today, 30th, and tomorrow on 31st Jan 2025. I hope you all will enjoy this knowledgeable and interactive session throughout the day. In this session, in total, we will be having 10 presentations of 10 presenters each. Each will be given a 8 minutes time span for presentation and 2 minutes for question and answers. I will be raising a gentle reminder on completion of 7 minutes. So this is a kind request for all the participants to please keep a track of time. Also, there is another request to all of the participants that you stay connected till the closing remarks. If you have any query, issue, or update, you can write it to me in the chat box and we will be solving it. Now, just before we get started, I would like to introduce you all to the session chair for today's session, Dr. Deepika Saxena. Good morning, ma'am. Thank you for joining us today. Dr. Deepika Saxena is currently serving as an associate professor at Pune University. With a PhD in cloud computing and over 15 years of teaching experience, she has demonstrated expertise in areas such as cybersecurity, container security, and cloud computing. Dr. Saxena is an active member of ACM and IAENG. Now, without any further ado, we'll start with our very first presentation today. So, the first paper title we have here today is an intelligent system powered navigation and IoT based solution for visually impaired individuals. And this paper will be presented by Kirti AJ from Vellore Institute of Technology. Kirti ma'am, you're there in the meeting, right?
Can you hear me?
Yes,
I'm sending the request for the presentation.
yes. Let me just stop sharing my screen.
Okay. I hope the screen is visible.
Yes, your screen. We can see your screen.
Okay, that's that. So, good morning, respected professors and the authors. This is Kirti, a fourth year integrated MTech software engineering student from Vellore Institute of Technology. I'm here to present a paper titled An Intelligent System Powered Navigation and IoT Based Solution for the Visually Impaired Individuals, along with my co authors Kalyan Sundaram V and Srinivasa Perumal R. Let me give you a brief overview of this presentation. We'll start with the motivation, background works, proposed methods, results, and conclude with the conclusion and the future works we are aiming to. The motivation behind our research is that visually impaired individual faces significantly challenging in navigation public spaces. Even though they use the canes or the guided dogs, the assistant offered was limited only. To propose the solution for this, we are aiming to bridge the gap by artificial intelligence and the IoT. So novelty in our system is that the system is uniquely integrates with the deep learning with the IoT, and the solution uses the transfer learning, fine tuning the pre-trained MobileNet V3 model. The device is cost effective, lightweight, and scalable. And we have focused on Azure custom vision also to track the model's performance. And the device gives the auditory and haptic feedbacks. The models we have considered is that four modules for object detection model, hardware module, feedback module, and evaluation model. For the object detection model, the SSD MobileNet V3 as a deep learning model to detect the obstacles such as vehicles, in there. And for the hardware, we have used two, which are camera model, which is OV7670, and the Arduino microcontroller to produce the response data. And for the feedback, we have used buzzers and for vibrators. And for the evaluating the matrix, the program matrix, we have used the Azure Custom Machine. Regarding the background work, we have taken more than 10 plus research papers for the we have found the matrices and the methods they have found and the problems they have faced. Based on the literature gap they have found between these 10, we have thought of taking the problem statement. It was helpful for us to build the solution. So let's come to the architecture and data set. This is the architecture that this hardware component is given over here. That camera module is connected to the Arduino, and the Arduino is connected to the actuators. For the data set, we have used a COCO data set. So the COCO dataset usually contains 330,000 images and 80 different objects such as car, people, and bicycle, which is helpful for the real time. So it also contains dataset is divided into testing and training. The COCO dataset we have chosen because it deserves the object categories, like it has a diverse category of an object, making the system capable for handling the real world problems. Coming to the proposed methodology, so as we discussed the modules in the before, in the input model, we have a camera model which gets the video stream from the environment. That is, the camera model has the capacity to send 30 frames per video. So that video is given to the frame extractor. The frame extractor will extract the frame from the image, from the video captured from the environment. That is normalized and given to the model. In here, in the Python pipeline, we have focused on the pre-trained SSD MobileNet V3 model, and we have fine-tuned the model, and it is helpful for the object detection. When the object is detected, it will give simultaneously an output with the interface engine and the actuators. So in the interface engine, you will be able to see that what are the detected object, and simultaneously it will give the car or the speed object, which is minute, and that is in the environment of the individual. Then the buzzer will be ignited, and if the persons are near over the individual, then the vibrator is ignited. So um, we have reduced the size. So we have resized the input images into 320 cross 320 pixels to ensure the capability with the SSD models, V3 model. And for the camera model, we have used OV7670 camera model. This captures the live video footage and gives to the Arduino, and the Arduino will gives to the Python pipeline. The Python pipeline will gets the input from the Arduino, and it will uh, uh, give the output to the Arduino again. So these are the results that we found in the Azure Custom Mission, as I said. So we have given the model and the data set to the Azure Custom Mission. The precision we got is that 95.8 percentage, and the recall we got is 95.8 percentage, and average precision is 97.0 percentage. These are the images that represents the output, where the image is detected as a person, or a tiny image is also detected by the mobile v3 model, and these are the connected real-time images. I would conclude the presentation with that the SSD model ensures the accurate detection with the low computational requirements, making it suitable for wearable applications. Our future works maybe will be adding more models and modules to the our Python pipeline, where it makes more computational, reduce the computational power, and gives the accurate answers. And we would also like to add the sensors, which are LiDAR or the depth sensor. To as for example, depth sensor is used for analyzing the depth of the surface, where which will be helpful for the individual if there is a slope or a staircase in front of them. And we will also like to integrate with the AI powered voice assistant for detail auditory navigation, which gives the idea of the environment. And we'll stay keep constant on the more affordable side, and it should not compromise our performance. Thank you for your patience.
Thank you, ma'am, for your presentation. Are there any questions from the session chair? If not, then we can proceed further for the next presenter. So the next paper title we have here today is Detecting and Predicting Hotspots in Urban Heat Island with Temperature, Humidity and Soil Moisture. And this paper will be presented by Muhammad Sania Sultana from Vegagapudi, Ramakrishnam Siddhartha Engineering College, India.
Yes, can I share my screen?
Yes, ma'am, I'll stop sharing my screen.
Okay. Is the screen visible?
Yes, ma'am, your screen is visible.
Okay. Okay. So, good morning, everyone. I am Sanya Sultana, and we are from Velakapudi Ramakrishna Siddhartha Engineering College, Vijayawada, Andhra Pradesh. So, we are going to talk about on the topic detecting and predicting urban heat islands with temperature, humidity, and soil moisture. So, what exactly is urban heat islands? So, as we know that the temperature difference between the urban and the rural areas is very high. So, in urban areas, the temperature is very high compared to rural areas. So, this is because of the increased temperature due to the limited greenery and all. So, this is called urban heat islands. So, this is because this has caused a very huge problem these days. There are many health risks and environmental degradation. So, for this, there have been traditional methods like random forest models and also in satellite imagery. So, but the problem with this is that these satellite images and all have been from a very long time and it's not updated. So, because of that, there is no like proper accuracy and all. So we have come up with a solution for spotting the heat islands in the Vijayawada region for now. So, and for this, we have used data sets from the NASA, and we have mostly focused on, like focusing on the accuracy and mean square error, less mean square error. So, we have taken the parameters. These are the most important parameters, that is temperature, humidity, and soil moisture. We have taken these patterns and provided actionable insights for urban heat islands to mitigate UHI effect and promote sustainable urban growth. So, coming to the literature review, as we have said before, the existing approaches like satellite imagery has been widely used for identifying UHIs these days, but it lacks with the temporal resolution. So, in machine learning models like random forest and ARIMA have been used for hotspot prediction, but have struggled with spatial and temporal accuracy. So the problem with this is that these existing models do not effectively capture the dynamic changes in the UHI, but also created limited forecasting. So we have come up with the solution with the long short-term memory networks. So these LSTM models are capable of capturing long-term temporal dependencies, improving both spatial and temporal prediction accuracy. So coming to the dataset we have used the dataset from the NASA, that is native resolution daily data, to collect the critical environmental data. And for this, the important parameters we have taken are the temperature. In temperature, we have taken both minimum and maximum temperature, whereas in humidity, we have taken relative humidity and the specific humidity. And its soil moisture, we have taken the ground level soil moisture. And for the pre-processing, first we have normalized using the min-max scaling to standardize the data values. And then we use the sliding window approach to create time series inputs and enable better temporal analysis. And coming to the methodology, this long short-term memory model was mainly focused on the RNN, that is recurrent neural networks for detecting hotspots. In this workflow, first, for the data pre-processing, we have first normalized and organized the data into the time series format. And then we have trained the model with the LSTM based on the historical data. And then we have detected hotspots like for predicting only temperature, humidity, and soil moisture patterns. And then we have visualized this. We have predicted these visual formats in the form of heat maps and time series charts. And the advantages of using this LSTM model is that capturing long-term dependencies in time series data, which has enhanced prediction accuracy. And this also improves, this is like the best approach over the traditional models by providing better spatial and temporal insights. Coming to the workflow diagram, as we know, we have collected the data set from the NASA, and then we have done the pre-processing using the load data set and normalized the data. And we also use the sliding window approach. Then, for the LSTM model training, we mainly focused on the RNN network, and then we predicted the UHI hotspots only in the Vijayawada region for now, using the important parameters of temperature, humidity, and soil moisture values. And then we visualize this in the form of heat maps and time series charts. Then coming to the result, compared to the previous models, we have got the least mean square error, that is 0.0026. This is the least which we have got, and compared to the other models, this was the best right now. And accuracy, we have reached to 94.88% with the current data we have. So the key insights for this is that the LSTM model accurately predicted UHI hotspots across different regions with higher precision than traditional models. And this model has improved temporal forecasting, allowing for better prediction, heat waves, and temperature fluctuations over time. So successfully, we identified hotspot patterns in urban areas of Vijayawada, contributing to more effective climate reliance, and we helped in urban planning strategies. So coming to the output, this is the output we have got visualized. The first one, as you can see, is the predicted temperature, and the second one is the predicted humidity, and the third one is the soil moisture. These are the values which have all the latitude and longitude values of these parameters. And this is the evolution matrix. First, this is the model detection. We have detected in the urban area, we have detected at what latitude and longitude there is a hotspot or not. And coming to this, we have precision of 92.36 and recall of 89.85. And this is the model loss image. Using these approaches, we have trained the model. And coming to the summary, this LSTM model has demonstrated strong predictive capabilities in detecting and forecasting UHI hotspots with higher accuracy. Compared to the traditional models, this has proved that it has better spatial and temporal insights. Coming to the future work, as we have right now done it only for the Vijayawada region, we are thinking of increasing the regions and also increasing the environmental parameters. As we have used only temperature, humidity, and soil moisture, now we are also going to add up wind speed and also the solar radiation to improve the predictions. And we are going to develop a real-time prediction capabilities for immediate decision making in urban planning and public health strategies. That's it. Thank you.
Thank you, ma'am, for your presentation. Now we'll proceed to the next presenter. So the next paper title is Enhancing Cryptocurrency Trading Through Artificial Intelligence for Optimal Investment Strategies. And this paper will be presented by Payal Ghode from Datta Megha Institute of Higher Education and Research, India. Payal ma'am, you're there in the meeting or any of the co-authors? I think she has not joined yet. We can proceed to the next presenter now. So the next paper title is Exploratory Analysis for Depression Detection Using Deep Learning Models, Internet of Behavior Approach. And this paper will be presented by Grishma Bobhate from Sandeep University, India. Grishma ma'am, you're there in the meeting, right?
Yes, ma'am. I'm in the meeting.
Yes, you can start with your presentation.
Okay. Is my screen visible?
Yes.
So the screen is visible properly, ma'am, as in slideshow mode.
Ma'am, try changing the slides, then I'll tell you.
Slideshow mode or in this?
Yes. It is full screen in the slideshow mode.
Okay, yes. So good morning, everyone. Good morning, Siddhi also, and good morning, the session chair, Dr. Dipti Saxena also. So I'm going to present my topic about the exploratory analysis for the depression detection using a deep learning model and interview behavior approach. So this is my the review approach before the starting of my the career of the in the this domain of the IOB, that is the Internet of Behavior, and I'm a research scholar from the Department of Computer Science and Engineering with the Sandeep University. So these are my contents. Today I'm going to complete these contents: introduction, motivation, review, and what is the existing result summary, analysis and discussion, research gap, what I found here, and then issues and challenges with the conclusion and references. So what abstract? The Internet of Behavior is nothing but it is a predictive learning approach between the behavior of the humans or the behavior of the predictions of that the human energy. So to explore that strategies in this behavior for the understanding of patient behavior and the mental health, then it will help to detect the depression. It also explores some different approaches where how the depression is been detected and then performance validations. Next part is what exactly the Internet of Behavior. Internet of Behavior is comprises with the IoT and intelligence. That is we can say it is a connection between the physical and digital objects where we can exchanging the data. Basically, this complete statement of IOB stands for the where the technology meets with the data analytics and the human behavior get analyzed. That completely goes to the IOB, means analyzing that IoT data, integrating with the human psychology, that is to understand the behavioral pattern as well as the trends that emerges the IoB. Next part is how the IOB plays important role with their structural component. Whenever we use the data can be from the IoT device, it can be a social media, or it can be committed from the online sections. So use data, then we understand the behavioral psychology. We analyze that behavior. If we importing any IoT data, then we uses that experiences of the users, and then we'll go to the product and services. Next is the IOB perspective. What exactly the IOB perspective? It is nothing but it is a study of that behavioral data, which accurately shows which accurately and using that a cutting edge technologies in spite of that the AI, blockchain, and digital tool. We can use this IOB perspective in this. So what exactly the IOB workflow? That is the data collection, standardization, where whatever the data collected, it is like a noisy data. So we mostly standardize those data and then we share that data to the components where we are approaching the learning models, and then the authoritative approaches will be applied. Authoritative analysis of that approaches. Next is about the role of Internet of Behavior in the society. Means basically the how the society plays a role. Means the IOB, wherever the data collected, it will monitor that behavior, analysis will done, and what will be the prediction is going, that will be the generated on the results. For example, if we take as a nutrition app, so when the humans takes the nutrition app, so exactly it calculates its sleeping time, physical activity, duration, and hydration power. And analysis of that, it will recommend ki what type of services or what type of you should take care of your body and you should take it. So it promotes your behavioral changes so that it recommends your food and exercise and habits also. Secondly, the background of the study is that Gartner's predictions, where the IOB impacts the Gartner's predictions that during the COVID-19, the IOB places important role, where the IOB take care of this over the 3 billion people by the 2023, and 40% of the world populations is expanding these Gartner's predictions. I mean, after the COVID-19, the IOB places an important role. It monitors the patient. Basically, it will works on the healthcare professionals where it monitoring the patients and accordingly the services of the medical regimens get provided. Next is about the what exactly motivates me, the human personalization. This is an automated system where we can scan the daily routine and perspectively we can improvise the skills. Next is what the motivations divides with the data analysis also. This IOB can be implements for our customer purchase and customer recommendation on the marketing analysis also. So this marketing analysis will recommend our company to grow upskills. Next is the technology integration. Technology integration means IoT device collects the data like Apple Watch as anything and draw its meaningful insights so that the human can change their behavioral perspective. Fourth is the sustainability. Nowadays, the sustainability is so important that you should continuous monitoring and upgrade yourself for to productivity. Fifth is the IOB in the healthcare, scheduling the treatment planning and individual psychology responses for the effective, meaning that should be implemented in the IOB. Next is the enhancement of the behavioral data. The motivation is that the real-time data is so noisy, so we should develop such a learning models to so that we can analyze those patterns and predict the proper execution of the product. Next is what this is the scope where this IOB can allow and where the deep learning models and exploratory how's the deep depression detection can go. Study of the behavior and then the deep learning models and then the data acquisition to ensure that privacy and security so that no hamper it will prevent you the healthcare department. Next is about the literature survey. So a literature survey has been divided into three parts. First one is the part with the ML part. Second one is about the deep learning part. Third one is with the IoT devices. And fourth one is the social media. So I've divided this literature survey. The first one is the introduction. So these are the surveys which are done by the various authors. How's the IOB person? If we starts with the June Yall to Muhammad Jal, the IOB has interacted for the user interaction with the IoT device. Next in that Dr. Deepa has shown the IoT collected, then the ADLIOB, that is the Advanced Deep Learning Framework, which has been embedded for the internet. Next, IOB, not only the deep learning, it also implemented with the explainable AI for the electrical conservation energy. Also, the Mohammad Jawel has shown this is how the IOB data are intervened from the users via with respect of internet customer services. Next, these are the interactions with other authors where the feature extraction done by the ML and deep learning models. Like this, the first author as Shubham has depressed the behavioral pattern with the SPM and NN. Sharifa extract that multilateral. Then cognition behavioral analysis where it
Ma'am,
not only features, yes.
ma'am, sorry for the interruption. Actually, we are past the presentation time. Could you please get to the conclusion?
Okay. Yes. So these are the content. So these are the data which are the literature survey has extracted from the IoT devices. So these are the authors we have worked for the we collected the data from the IoT devices. Next is from the social media. Here the multi-model depressive dictionary learning pattern to the RNT OLSTM methodology has been introduced. So these are some surveys on the existing learning model using the deep learning. Okay, so these are the existing result summaries. From this result summary, analyze that there should be a fine-tuned model for to optimizing the solutions, and the behavioral analysis should be patterned in such a way so that the noisy data can be used to predict for the better healthcare. And these are the performance validation can be used by the deep learning methodology. So these are the gaps which is found. Next is what this is the issues and challenges, privacy and security is not only to empire but also to ensure. Next is the data analysis of the data, absence of the authority, the data integrity, accuracy, and data ethics and law. So my perspective of the proposed methodology, this is a dark circle down is my where I'm main circulating the points. My behavioral data learning model and the depression scale, BDI to 1 PHQ. These are the two measurement scale to detect the depression. This is my main contribution where I work more for predicting. Next is about the mood. So this is the what you can say the conclusion about the human behavioral analysis. Psychological features should be insightful, and it give the potentiality for not only in the detection of the healthcare but also in the contextual and mood monitoring. Also, it should also provide the privacy for the data and also customizing so that the workplace becomes your productivity and become a recommendations. So these are the literatures. Sorry, these are the references where I referred all these things. Okay. Thank you.
Thank you, ma'am. Now we'll proceed to the next presenter. So the next paper is improve. So the next presenting paper is improvement of power reliability in rural India using isolated energy storage systems. And this paper will be presented by Bala Subbareddy Mallala from Chaitanya Bharati Institute of Technology. Sir, if you're there in the meeting, could you please start with your presentation?
Yeah, good morning, madam. Azka, please share your screen and proceed. My scholar will do this.
Okay.
Good morning, everyone. So, my paper title is Improvement of Power Reliability in Rural India Using Isolated Energy Storage System. So, as we all know, the in India, the power is transiting from not only in India but in the whole world. Power is transiting from conventional energy sources, which were various coal and other thermal energy generation systems, to a renewable energy system, which is a more cleaner energy system, and also has the ability to meet the energy demand of the consumers. But there was a very much big disadvantage of renewable energy system, because as it consists of major renewable energy sources such as solar PV plant and wind energy system, but both of them had a large amount of drawback. That is, they are both intermittent in nature. That means that they are not available continuously throughout the time. So for that reason, I have uh, prepared this paper. In this paper, I am going to discuss about the uh, 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 interconnection of solar PV plant along with a fuel cell and along with a battery. So here's a problem statement: the dependence on the fuel cell and as well as intermittent renewable energy. So for that solution, I have prepared a solar PV plant integrated with the energy storage system as well as a fuel cell. Uh, The objective of this project of this paper is to supply reliable power to rural India, reduce the dependency on conventional grid, and also utilize the green hydrogen and renewable energy. And the major part will be to develop an energy management system, which with which we can seamlessly transit from one energy source to another. So these are these parameters for this paper. This is the block diagram. In this, you can see the fuel cell along with solar plant is connected to an inverter, which is carrying the supplying the load. Then there is also a battery energy storage system with a bidirectional inverter and supplying the load. This is the simulation diagram. Uh, uh, as I've told earlier in the block diagram, it is the same thing. So the operation time in this there are two operating modes. Uh, During the first mode, during 0.5 to 1.5 second of simulation time, the PV system along with fuel cell supplies at the same time. And during the second mode, whereas the battery is supplying the load from 1.5 to 2 seconds for simulation time. For simplicity, I have taken only 2 seconds, but it can be taken and applied for 24 hours as well. So these are the simulation results. Here you can see we are having a total load of 100 kilowatt. From that, 80 kilowatt is shared by the PV plant, and the remaining is uh, shared by the solar fuel cell. That is approximately 20 kilowatts. And then that is that they are sharing the load from 0.5 second to 1.5 second. From 1.5 to 2 second, the simulation is run with the battery. Here you can see clearly the amount of power is shared by the solar PV. That is approximately 83 kilowatt. The remaining is the is at 21.16 is shared by the fuel cell. This is the approximately 104 kilowatt load. So the battery versus load demand is given in this graph. the battery is generating approximately 7.44 kilowatts. So the main idea behind the designing of this kind of system is to uh, uh, when the sunlight is available, the solar is going to share the load. Then when it is unable to meet the complete load demand, then the battery will assist it, and when there is no sunlight, the fuel cell along with battery can work. The advantages: the simulation reduced to 2 seconds for analysis purpose. The results demonstrate seamless energy transition uh, between the solar solar PV plant, PV cell, fuel cell, and battery. Then the stable voltage at load terminals can be seen. The reliable backup power through a energy storage system can also be seen. So conclusion: the integrated system comprising of a fuel cell, photovoltaic cell system, along with the energy storage system, is designed to efficiently supply the power to the load. The performance of the system under various operating modes is analyzed, demonstrating its ability to transition seamlessly from different modes while maintaining the stable voltage at load terminals. This system also enhances both system reliability and efficiency. Furthermore, the energy storage system ensures adequate backup power is available during evening hours when the solar radiation is absent. Thank you. These are the references, and thank you.
Thank you, sir, for your presentation. Now we'll proceed to the next presenter. So the next paper title is Integrated Real-Time Object Detection and Navigation Framework for Autonomous Vehicles on Raspberry Pi. And this paper will be presented by Pradeep Kumarji from KPR Institute of Engineering and Technology, India. Sir, you're there in the meeting. Please respond if you're joined the meeting.
Hello, ma'am. Good morning, ma'am.
Hello, good
Yeah,
morning.
good morning, ma'am. Ma'am, I'm in a meeting, ma'am. My scholar Priya will present this, ma'am. Priya Devi.
Sure, sir. I'll stop sharing my screen, then you can start with your
Yeah,
presentation.
thank you.
Hello. Priya ma'am, you can start with the presentation.
Am I visible?
Yes, your screen is
Is
visible.
my presentation is visible?
Yes.
Okay. And my paper title is Integrated Real-Time Object Detection and Navigation Frameworks for Autonomous Vehicles and Raspberry Pi. Authors are Pradeep Kumar Ji and Priya Devi, Suji and Gopinath and Dhanapal. Here are the objectives. The main objective of this paper is to reduce the human driving errors to enhance road safety, and to lower the accidents rates to advanced navigations, and to improve fuel efficiency via optimized driving decisions, and to enable real-time obstacle detection and path planning. And here are the abstract of this paper. When your self-driving cars face challenges in India due to erratic roads and unreliable GPS. Here we have proposed a hybrid navigation system combining pattern matching and sensor-based technologies. Here the Raspberry Pi process real-time road imaginary for accurate pathway identifications. And the sensors also detect and avoid obstacles and ensuring safe and autonomous navigations. And the prototype improves the road safety, reduces the human errors, and enhances the fuel efficiencies. And here are the introduction. Self-driving cars or autonomous vehicles use advanced sensors like radar, cameras, and AI algorithms to navigate without human interventions. Drastically reduce traffic accidents up to 94% caused with human error. improve fuel efficiency and lower emissions, contributing to environmental sustainability, and enhance mobility for sensors, disabled individuals, and underserved areas. And here are the literature review. In the first title paper, integration of deep learning algorithms for enhanced perception in self-driving cars. And this paper explores the application of deep learning algorithms to improve the perception system in self-driving cars and emphasizes the enhancement of object detection, decision making, and environmental awareness. It integrates advanced AI techniques, significantly boosts the safety and reliability for autonomous vehicles. And here are the second paper. It explores the real-time obstacle detection and avoidance for self-driving cars. It published in 2019, and this paper explores the real-time obstacle detection and avoidance system for self-driving cars. It presents a novel algorithm combining sensor fusion and machine learning to detect obstacles and adjust vehicle paths dynamically. And the results demonstrate improved safety and efficiency in autonomous navigations. And here are the another two papers, and it represents the integration of reinforcement learning algorithms in self-driving cars. It was published in 2022, and this integration of reinforced learning RL algorithms in self-driving cars focuses on enabling vehicles to learn optimal driving strategies through trial and error interactions with the environmental and RL techniques, that is reinforcement learning, are applied for tasks like decision making, land changing, and collision avoidance. And the last paper, that is a real-time object detection and tracking for self-driving cars using deep learning. And this emphasizes the leveraging deep learning for real-time detection and tracking of objects in autonomous vehicles. Models like YOLO, SSD are utilized to ensure fast and precise object recognitions. This improves environmental perceptions, promoting safer and more efficient self-driving systems. And this is the existing system. In current vehicle automation systems are primarily designed and manufactured in foreign countries and presenting challenges for domestic implementations due to difference in driving norms, such as right-hand versus left-hand traffic rules, and higher traffic density in India compared to developed nations, which may reduce the effectiveness of these systems in local conditions. And here the proposed method, and the system uses a pattern matching with cameras to detect specialized patterns on road surfaces. Onboard cameras capture these patterns processed by Raspberry Pi technology to give navigation instructions. And the camera also captures images of surroundings to identify the nearby obstacles. The vehicle stops if an obstacle poses a collision risk until it clears. And special patterns along roadway help identify upcoming and road types and conditions. And here is the block diagram. And in block diagram, we have Raspberry Pi. From that Raspberry Pi, sends the captured data, that is video, to the remote system, and it sends the processed information to the Arduino, and then it is and sends its instruction to the modeled car and to the Pi camera, where it captures the images. And here are the explanation of this block diagram. The primary goal of this design phase is to create a detailed plan to address the specified requirements, ensuring a successful transition to testing and maintenance. Designing a system for a model car that autonomously navigates roads based on real-time data. Key components and workflow include a Pi camera captures real-time footages, and a Raspberry Pi analyzes the footage to detect obstacles or road patterns. Data is sent to the remote system for advanced analysis via machine. And the process data is relayed to an Arduino, which controls the model car's movements. The car adjusts its path based on the road patterns, obstacles, or user inputs. And here is a developed model of a project. We have connected a Raspberry Pi with a camera. And here's the explanation. It utilizes a Raspberry Pi camera system for real-time environmental perceptions and onboard image processing. Radio wave communication enables remote processing for obstacle detection and navigation commands. Commands include speed, direction adjustments, lane changes, and obstacle avoidance for dynamic environments. Emphasizes affordability, accessibility, and equitable distribution of self-driving technology benefits, and implements robust cybersecurity measures to mitigate hacking, data breaches, and unauthorized systems. And decision-making algorithms control speed, braking, and steering in real time. Machine learning improves performance through data collected through during operations. And here is the conclusion. Proposes a system that reduces human intervention in vehicle operations and demonstrates superior performance compared to average users with reliable results, efficiently detects special patterns and identifies obstacles in the surroundings, successfully fulfills all project objectives, and mitigates common human errors during vehicle operations. And here are the future works. And here we can develop a web application to enhance project functionality, enable user interaction when the vehicle encounters multiple pathways, provide users with suggestions for nearby places to visit, enhance user experience and convenience, improve system usability and versatility for evolving user needs. And here are the references. And thank you.
Thank you, ma'am, for your presentation. Now we'll proceed to the next presenter. So the next paper title is IoT Enhanced AgriBot, using image processing and machine learning for effective pest management. This paper title will be presented by Dhana Lakshmi from Sri Krishna College of Technology, India.
Am I audible, ma'am?
Yes, ma'am, you're audible.
Okay, sir. Answering, sir.
Is my screen visible, ma'am?
Yes.
Okay. Good morning, everyone. I am Dhanalakshmi from Instrumentation and Control Engineering, Sri Krishna College of Technology. And I'm presenting our research on IoT enhanced agribot using machine learning and for effective pest management at SMARTCOM 2025. This work is a collaboration between Prashant Hariprasad, Dr. J. Dhanaselvam, and Mr. Arish. And I'm honored to share our findings with you today. Yeah, coming on to abstract, and India is an agricultural nation. It challenges like pest infestations and crop diseases significantly impact productivity. The excessive use of pesticides has environmental and health risks. Our research aims to develop an autonomous robotic system integrating IoT, deep learning, and image processing to optimize pesticide application and promote sustainable farming. A proposed system aims to bridge a gap between traditional farming techniques and modern precision agricultural solutions. So coming on to introduction, in agriculture we use pesticides. It is an integral part in the worldwide. Between 30 to 35% crop loss are prevented using pesticides so that it can remove harmful insects and diseases. So in current methods for pesticide application, we use human operator traveling along the crop rows and selectively spraying the targeted manually using the backpack sprayer. You can notice that image which is in right side. It's a human spraying method, and mechanized non-selective spraying is when human drives a tractor with a sprayer connected to a trailer so that they will spray the pesticide to the crop selectively. So this will be more poisonous and harmful for humans and the environment. So coming on to problem statement and justification, traditional pesticide application methods often result in insufficient spraying. Either it may overspraying or underspraying. Additionally, real-time monitoring of soil, moisture, humidity, temperature is crucial for farmers. So our system addresses these challenges by ensuring precision pest detection and targeted pesticide spraying. By incorporating advanced imaging and AI, we can reduce the adverse effects of effective pesticide usage, leading to healthier crop and improved efficiency. So coming to the solution, we proposed a deep learning based pest classification system integrating with an autonomous robotic sprayer The robot navigates through the field, capture images, and processes them using image segmentation techniques to identify the diseased leaves. If a pest is detected, the robotic system applies pesticide only to the affected areas. It won't underspray or overspray, reducing the chemical usage and environmental impact. This approach not only enhance the precision but also minimize the operational cost for farmers. So coming on to the block diagram, we could notice that our system follows a structured workflow. It starts with the image acquisition, uh, then it followed by pre-processing and segmentation. We used an RNN and quadra attention fusion method so that it enhanced the low resolution test images. Actually, it improves the quality and clarity of the image. ResNet helps retain image details through residual learning. Quadra attention is improves pest detection accuracy. If once the pest is identified, a target spraying mechanism is activated. The entire system operates using the Arduino Nano based robotic module and then motor driver for the movement. We use L293D motor driver for the movement. The modularity of the system ensures easy scalability, adaptability for different crop types and farm sizes. So this is a proposed methodology. We follow 4 steps for this approach. First is a capturing image of plant leaves using an in-camera system. So that camera, with the help of camera, input image is captured and it is fed in PC. So that input image is segmented. We could notice that red, yellow, blue segmentation mask is detected, which is an pest affected leaf. Uh, it divides in an array form and it is converted into first convolution layer weights, applying instant segmentation to different healthy and diseased regions. This is the second step. And third, we use a deep learning model to classify pests and diseases so that we could identify the in third step, we could identify the pest affected areas. And here is a pop-up message which we will receive in an PC so that what type of disease it is and what type of fertilizer we need to use. Disease name is disease name is anthracnose disease. Fertilizer is nitrogen fertilizer. In left graph, we could notice the validation accuracy, which is 99.80%, and percentage of loss in the below diagram. And this is the another input image we used. So that segmentation mask, after segmentation mask, we can see the first convolution layer weights, which is pest affected areas, and last what type of disease name and what type of fertilizer we need to use. These are the simulation output we got, and uh, validation accuracy is 99.80.
Ma'am,
Additionally, additionally,
sorry for the interruption. Actually, we are past the presentation time. Could you please get to the conclusion?
yes, ma'am. So additionally, our system features a self-learning mechanism, improves the accuracy over time. And coming on to the conclusion, the system displays pest details, predicts suitable treatments, and automatically sprays the appropriate pesticide. The simulation output includes disease classification, segmented image, marking affected areas, and real-time pop-up message. And major advantages using this machine is like precision spraying, cost effective, eco friendly, improved productivity. And in summary, we could conclude um, our project effectively integrates image processing and deep learning to optimize pest application. And our project matches the sustainable development goals of an uh, affordable and clean energy, climate action, and life on land. So these are the references we used for our project research, and thank you for your patience.
Thank you, ma'am, for your presentation. Now we'll proceed to the next presenter.
Thank you.
So the next presenter, the next paper title is Predictive Modeling of Forest Cover Types Using XGBoost and Hyperparameter Tuning. And this paper title will be presented by M. Kavita from Hindustan College of Arts and Science, India. Kavita, ma'am, you're there in the meeting, right?
Yes, ma'am. Yes. Am I
You
audible,
can
ma'am?
start with your presentation now. I'll stop sharing my screen.
Okay. Is it visible?
Yes.
Yes, thank you. So good morning, everyone. So today I am going to share my research paper, Predictive Modeling on Forest Cover Type using XBoost and Hyperparameter Tuning. So this paper basically deals with the forest cover type prediction because it is playing a vital role in environment monitoring, sustainable land management, and biodiversity conversion because it helps for informed decision making. So it is a challenging task to conserve the planet's ecosystem and vital resources. What is the problem with the existing system is it is struggling to capture both the spatial and temporal dimensions. So those spatial and temporal dimensions has been clearly identified and predicted by using random forest. Now in this paper I have focused mainly on the multi-class classification by using the gradient boosting algorithm along with the hyperparameter tuning. So this evaluates how well the algorithm handles the class imbalances and how it is predicting the specific forest cover type. So it enables us for informed decision making for conservation efforts, optimal resource allocation, proactive strategies, and also to mitigate the impacts of climatic change on the forest ecosystem. So the primary objective of this is basically the system effectively captures the data patterns across the most classes, and the paper covers the inhabitants of the forest, deforestation, and forest fires. Random forest algorithm predicts the results and achieves good results, but with the help of this gradient boosting the machines, we can analyze easily the different types of classes which we have with the forest cover type, and we can easily predict what is happening in the dense forest, open forest, or a combination of both the things. So the main objective is to detect the early signs of ecological disturbances, habitat loss, or illegal logging activities. It aids in making informed decisions related to forest management and biodiversity conversion. The task of forest recovery holds immense ecological significance, gives an consistent decline for forest areas due to factors like fire and human activities. There is an urgent need for robust efforts worldwide to swiftly restore our forests. So problem definition is actually the high forest is expected to decline by 50.1% in 2022, and it is going to be declined to 40%. So this forest cover type on different classes needs to be predicted. There is a need to recognize the variety of trees available in different parts of the forest, and we can also predict the forest fires, ecological disturbances. All those things needs to be addressed. So that in this paper, I have used the repository, UCA repository of forest cover dataset, which includes these features like elevation, slope, soil type, wilderness area, hill shadow, morning and noon, or 5 points. These were the attributes which we have in the dataset. So this randomized searching is done on hyperparameter instead of tuning all the parameters. So it helps us to find out the optimal set of hyperparameters. It is best suited when large space is used. It requires less computational power and becomes faster because it does not evaluate all the combinations. And this gradient boosting is a machine learning model, which is it uses a decision tree to perform classification, regression, and ranking tasks. It is a supervised learning algorithm. It uses the depth first strategy to grow the trees, results in deeper and more finely optimized trees because it ensembles the previous one and what are all the errors which we have already, and that will be rectified in the next one. And it is fast and scalable. Cross-validation method is used to evaluate the machine learning model performance, and to validate it, it randomly divides the data set into 10 parts or folds and then testing model on each fold. So as I told you, the extreme gradient boosting is a tree-based n-assembling learning algorithm that builds multiple decision trees sequentially when each new tree corrects the errors made by the previous one, and also it minimizes the loss function through gradient descendant optimization and the model by adjusting the weight based on the residuals. For hyperparameter tuning, this randomized search CV was employed, which randomly samples different combination of hyperparameters like maximum depth, learning rate, and n estimators to find the optimal configuration. So initially the data were collected and the pre-processing were done. In the pre-processing, we will done the scaling and normalization, and then data will be splitted, and the model were built by using the gradient boosting method and with the help of hyperparameter tuning. And model optimization can be done by checking with the MSC and log loss to identify the error rates. And finally, the forest cover type prediction has been done. This is the implementation result by using the confusion matrix. The row represents the actual classes and the column represents the predicted classes and the error rates and the rate in which the MSC has been calculated. This is the success ratio of the different types of classes of forest cover type and the hit ratio of the different classes. And this is the hit ratio of gradient boosting in different parameters like elevation, slope, aspect ratio, and based on that, the graph has been shown. So I am concluding my paper that as the forest cover type prediction plays a vital role in today's environment. So the proposed method helps to predict the forest cover type and performs well across most classes. But there is some imbalances and refinements needs to be done on done on some of the classes because it is not giving you the actual thing for all the classes. There is some imbalances in your in some of the classes. Those things needs to be refined and needs to be improved in accuracy in the challenging cases. These are the references which I have done. That's all. Thank you.
Thank you, ma'am, for your presentation. Now we'll proceed to the next presenter. So the next presenter we have here today is again a paper title by Pradeep Kumar ji from KPR Institute of Engineering and Technology. And the paper title is Wireless Sensor Network Optimization in IoT Landslide Detection Systems Using ZigBee Protocol. Pradeep Kumar sir, if you're there in the meeting, could you please start with your presentation?
Ma'am, he's in meeting. I will present this, ma'am.
Yes, sure, ma'am. You can just start.
Ma'am, does my screen is visible?
Yes, ma'am. Your screen is visible.
Okay, ma'am. Good morning. Myself, Patra Madi. I am a PG scholar and my guide name is Pradeep Kumarji, Assistant Professor, and my topic is Wireless Sensor Networking Optimization in IoT Landslide Detection System using a ZigBee Protocol. Now we discuss about the objectives. To continuously monitoring key landslide related parameters, also for to improve the detection accuracy using advanced algorithm and the models. Here we discuss the providing timelines warning to Stackler for productive responses. Here also ensuring the seamless integrations with IoT platform for a certainized data management and scalability. Here we can also implement the abuse development and strategies for reliable operations in the hazard areas. Here is some of the introductions. Due to landslide poses a major threats to be lived in an infrastructure requiring an advanced system to provide a timeline warning and improve the disaster management. Here the real-time landslide monitoring, the ZigBee enabling the IoT platform, collect, analyze environment in data such as soil moisture, perception, temperature of the ground motion. The system integration wireless sensor network, cloud computing, and a Blink app will be used here, providing a real-time data access, also getting some alarms, notification for the time decision making and responsibilities. Here we mainly used as a ZigBee technology and the IoT enabled and efficiency monitoring network, offering a significant advancement, landslide detection, and hazard mitigations. Here are the some of the literature reviews. In the paper, one landslide detection and the monitoring system using wireless sensor network. It will discuss about the using a sensor monitoring identification fault areas in the year of 2014. And the second paper will go for IoT enabling plant soil moisture monitoring using wireless sensor networking. Here is also using a wireless sensor network integrated with a IoT employing with a EMW algorithm to enhancing the network lifetime. Yeah, it was published in the year of 2017. Next, go with the next paper. Here is the IoT-based environment monitoring system using Arduino Uno and the ThinkSpeaker. Here is using a strong data on a ThinkSpeaker and providing a update using IoT sensor to monitoring the environmentals. And the last paper will discuss the estimation of the soil moisture using a morphing antiquate preparation index with applications in the landslide predictions. Here is a holding a capacity demonstrating soil moisture and prediction components. This was discussed in the year of 2019. And now we go with for a problem statement. Here is a lack of problems we discuss. The first one is lack of real-time monitoring. In real-time monitoring, the monitoring system do not provide a real-time data, so that making it difficult to detect and respond to the protection landslide remotely. In technical integrated challenge, the Zigbee-based measurement established in IoT platform faces related interpretation and scalability, energy efficiency. Data interpretation and visualization was created by the better tool to interpret and visualize the landslide data, help us make to inform their decisions. Next, to go with the existing system. Human activities have a casual acknowledges implementers and a landslide that result a significant loss of life and property. So that we are using this project focus on the detection of soil erosion and landslide in earth dams, which are subscribed to an environmental changes. In the dam, earth is influenced by water content. So it increases water, raises the plastic limit, reducing the soil sharing strength. Now we discuss about the proposed system. Here the proposed system architecture for the landslide, flood monitoring and a notification is designed and implemented to optimize the resources. In flood monitoring system, low cost and low power and long distance data transmissions will be occurred here. Next with the block diagram, here is the sum of the block diagram. We are used the sensors like a moisture sensor, rain sensor, MEMS sensor and a vibration sensors. In vibration, in floating monitoring, it will be transmitted to the Arduino Nano and the power supply will apply. The LCD display will be displays the command. The buzzer will use to sound. The Zigbee will be used to transmit the data. Here are the sum of the Zigbee USB interface and to paste an IoT website using it will be moved. Say this is the same example of this one. Zigbee sensor tracks soil moisture, temperature, humidity, and rainfall in landslide prone areas. This system processes data to detect early sign of the landslide. Alerts are sent to others and the public risk to detected. Users can check the real time and pass data through a web or a mobile apps. The system enhances power, efficiency, security, and the regular maintenance for a smooth operations. Here is the development of the model. The block diagram of Zigbee-based landslide monitoring connection side view, and the transmitter and receiver. Here is some examples. Research and planning, study the existing system, define requirement and identifying the improvement. Sensor and network setups, choose a sensor integrated with the Zigbee and design an efficient networks. Data collection and transmission, develop a firewall to collect, compress and transmit sensor data reliability. IoT and the Blink integrations connected to an IoT platform for a real-time monitoring, alert and remote access. Testing and developments, validate accuracy, deploy in landslide prone areas, and continuously improves the system. Here is the methods. Landslides are a major threats to live property
Ma'am,
Yes, ma'am.
sorry for the interruption, but we are past the presentation time. Could you please get to the conclusion?
Yes, ma'am. Some of the conclusions here. The development of the Zigbee perimeter evolution system, IoT platform for a real-time landslide monitoring, enhancing the disaster realizes and reduces the landslide risk. By utilizing Zigbee wireless connection, sensor technology, and advanced data analysis, the system provides a continuous monitoring and early detection of the landslide risk. Through deep sensor deployment, data analysis, and the stakeholder involvement, it develops valuable insight into the environment condition and a potentiate landslide hazard, enhancing the time risk management. Here is the future scope. In future works, better sensor and the data processing, adding more sensor methods, multi-hazards monitoring will be in future scope. Some of the references I have taken by this. These are my references. Thank you, ma'am.
Thank you so much, ma'am, for your presentation.
Okay, ma'am.
Now, before proceeding to the closing remarks, lastly, I want to call out for Shailish Gahane. Sir, if you are present or anyone from your team is present in the meet, please proceed with your presentation. I think he's not there, so we'll proceed to the closing remarks. Okay. I sincerely thank our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on the behalf of whole team, thank you for the support during the ninth version and all the previous 8 versions of the conference. We will be happy to have you in the 10th version in 2026. All the presenters would be getting their digital certificates via email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of SMARTCOM 2025. Lastly, I also would like to thank our session chair, Dr. Deepika Saxena, for chairing this session. A token of appreciation to the chair on the behalf of Team SmartCom and Global Knowledge Research Foundation. Thank you for your valuable presence. Now, lastly, before ending this session, I request all the participants to please turn on your cameras so that I can take a quick snapshot of today's session. Okay, I've taken the screenshot.
Ma'am, I cannot start my video. Kavita.
Okay, we'll just wait for a minute for her, then we'll take one snapshot again.
Actually, it is telling that the host has stopped it.
It's okay, no issues. I've taken the snapshot. I just wanted an overall snapshot of all the participants. Okay, then on this note, we are free to end this session. Thank you all for presenting your papers.
Thank you.
Thank you.
Thank you, ma'am.